Hello Explorers. Today we're going to use our acceleration graph, our speed graph, and our altitude graph to measure different components of a projectile object, this ball, as I throw it up into the air. Now, we're going to use those observations to draw some conclusions about the acceleration of gravity and about how acceleration and forces are related. For this lab, you will need your PocketLab, a device to measure the data with, and some type of ball where you have hollowed out part of it so that the PocketLab can fit inside. Okay, so in this lab, we're going to be analyzing 3 different graphs, but you're only going to be able to see 2 graphs at once on the screen. So you're going to want to turn on the speed graph and the pressure altitude graph. By turning on the speed graph, we'll also be able to go back and look at the acceleration scalar data because the speed graph uses the accelerometer. So it's really important that you have those 2 on because you'll need to zero those to collect the data. So I've placed the PocketLab inside of the ball. Now I'm going to go ahead and zero my data and record, and I'm going to throw the ball up a few different times. Okay, so let's look at in a little more detail at what's happening to the speed of the graph. Right here at the very top of this graph, this is actually the release of the throw. So it may seem like, well, is this slope going up? Is that when the ball is traveling up, and then this is when the ball gets to the very top, and then this is the ball going back down? But no, that would be that's shown in the altitude graph. This graph is showing the speed. And so right here, the ball isn't moving. The speed is 0 meters per second. Right here, I bring the ball down to throw it up. And then as I'm throwing the ball up, I'm applying force in the positive direction. And as I'm applying force in the positive direction with my hand, I'm also moving the ball up in the air. And so if I'm applying force in the direction of movement, then the ball is going to speed up. And so that's why you see the ball here speeding up. So that's why it's really important to draw your free body diagrams to see what's happening. So here, the net force during the throw is applied force from the hand, pushing the ball in the direction of movement, speeding the ball up. Right at this moment, as soon as the ball is released, the ball is now immediately in the air. And as soon as the ball is in the air, there is no longer any applied force from the throw, and all of the net force comes from gravity. So our net force is from gravity. Well, if the net force is from gravity, that's pulling the ball down, even though the ball is traveling up. And so when you have a net force against when you have a net force against the direction of movement, that's when you have negative acceleration, and that's when you have an object slowing down. So that's all thinking about Newton's first law there. And right here, the ball is released, and you see this negative slope. Well, what does a negative slope mean in this graph? Well, what it means in this case, when we're on the positive side of the graph, here's 0 right here. So when we're on that's 0 meters per second. So when we're on the positive side of the graph, if the slope is going down, then what's happening is that the speed of the ball is getting closer and closer to 0 meters per second, which would be stopped. So if the ball is getting closer and closer to 0 meters per second, then the ball is slowing down, and that's something that you want to point out with your students. So they may say, well, this is when the ball is going down, but actually that's when the ball is going up. The speed of the ball is just approaching 0 meters per second, which means it's slowing down. Now, right here we see something very interesting. Here, you'll see that the ball will be approximately 0 meters per second. If the ball is approximately 0 meters per second, well, that means the ball isn't moving anymore. And that may be something where your students say, well, I don't see the ball like stopping in midair, but maybe they do, they just don't, we're just not thinking about it in that way. Here, let's think of the ball traveling up. So I'm not drawing the net force anymore, I'm drawing just sort of the movement of the ball. Here's the ball going up, and as it goes up, it slows down, and it reaches its apex, it reaches the very top of its height, And at that moment, the ball must turn around and head back down. Well, if the ball is going to turn around, it's got to slow all the way down to 0 meters per second. And then on its way down, it'll then start speeding up because on its way down, it's traveling with the net force. And so when you have a net force in the direction of movement, you get positive acceleration. You get the ball to speed up. So in this moment here, when the ball actually turns and heads down, the ball for that split second is traveling at 0 meters per second. So your students you are actually seeing the ball stop and change, and you're seeing that through the change of direction of the ball. Now here, when the ball is traveling down, we still have the net force of the ball also going down, so you have the ball actually speeding up. But we see that in kind of an interesting way here, and this is a great way to work on some graphs with your students. But here, this is when the ball is going down. The slope is still negative, just like up here. Up here, a negative slope, though on the positive side, a negative slope means it's slowing down. On the negative side of this graph, a negative slope will mean it's speeding up. And why is that? Because the speed is really the absolute value. And so as the slope is going down, it is getting farther and farther and farther away from 0 meters per second. And if it's getting farther from 0 meters per second, that means it's getting faster. So up here, negative slope on the positive side means it's getting closer to 0 meters per second, which means the object is slowing down. It hits 0 meters per second, changes directions, starts traveling down, and as it travels down, the speed is getting, on the negative side, is getting farther and farther from 0 meters per second. So while it's a negative slope, it actually means it's speeding up. Let's take a look at acceleration now. Okay, so now let's take a look at how that all relates to our acceleration graph. And I think this is just really cool. So you see that we have this acceleration here, and this actually corresponds again to the throw, because that, again, is where our applied force was going up. We had that applied force in the positive direction. So so when I threw the ball, I accelerated the ball upward. Here, the ball was released. And then as soon as the ball was released, the net force causing the acceleration, as soon as the ball was in the air, was from gravity. And gravity accelerates all objects at approximately 9.81 meters per second squared here on Earth. And so as soon as the ball is in the air, you get this acceleration that's really consistent right here. And that's at, the reading here, it reads negative 9.65 meters per second squared. So that's right around 9.81 meters per second squared. And you get that whole line of data points right there. This is the acceleration for the graph the entire time it's in the air, on its way up and down. And so you can use this to really think about the value of g and how the force of gravity is equal to mass times the acceleration due to gravity, and the acceleration due to gravity here on Earth is always going to be around that 9.81 meters per second squared. Right here, this change here is when the ball was caught. So that's why you see this acceleration in the other direction. This is when the ball is being caught.